In this video, let's try to look at the next password encoder provided by Spring Security, which is Pbkdf2PasswordEncoder. The name looks very weird, but there is some meaning behind the name. Pbkdf means password-based key derivation function 2. And this password encoder is a pretty stronger than whatever we have seen previously, like no op password encoder and standard password encoder. The reason is, on top of providing a feature of secret or solve for our hashing, it also has two other parameters. One is how many times you want to iterate for encoding, and at the same time, what is the length of your hash that you want to generate. The more the length of the hash and the more number of iterations that we choose, the stronger your hash will be for anyone to decode it. But it comes with its own drawbacks, like it's a slow hashing mechanism since it will perform so many iterations and it will take enough measures to maintain that length of the hashing. Due to that reasons, this password encoder is slow compared to other encoders available in the Spring Security. And to use it, we have three options. One is where you can directly create a simple constructor without any arguments. That means I don't want to mention any secret, and at the same time I want to go with the default iterations and the default length of the hash code. And the next constructor is where I'll pass the secret that I want to use, and I'm good to go to use the default values of the number of iterations and the length of the hash. Last one where I have an option of providing the secret, number of iterations that I want, or the length of the hash that I want to generate. So usually by default for all these constructors, Spring Security considers 185,000 as the number of default iterations that it will go, and 256 is the length of the number of bits that a hash can contain after generating a hash outside a normal text using this password encoder. So these are the three different constructors available. Let's try to go and look in the code also. So this presents in the same package like any other password encoders, and it implements password encoder. And here you can see if I'm not specifying through my constructors, this encoder will consider default hash width as 256 and default iterations as 185,000, and I'm always have an option of overriding them to make it even more stronger or to reduce the complexity of the hash by decreasing these numbers through the third constructor that we have seen. So here there are three constructors. First one is which won't accept anything, and if you're not passing any secret, that will call this constructor internally with empty string, where empty string will be used and default iteration and default hash width will be leveraged. Or you can also directly call this constructor by passing a secret, where default iterations and default hash width will be used, followed by we also have a constructor where you can customize as per requirement by passing the secret, iterations, and the hash width. Suppose that we have encode method, which is a override method. This method will be used by Spring Security to convert my original text of the password into an encode or encryption by the algorithm, by the salt, and the other parameters that we have chosen. And at the same time, we also have a matches where it will try to compare after converting or encoding my raw password with already encoded password in the database. It will try to compare both of them. If they both matches, it will give a boolean as true. But again, you can see here, this is not a completely one-way hashing. Due to that, though it is far better than standard password encoder, for the reason that it is doing more iterations and it is allowing us to mention the password length, but still this is not recommended to use when compared to bcrypt and script password encoders. So let's try to look into a script password encoder in the next video. Thank you and bye.